right? So let's go ahead and use the square root property to solve some of these equations. Now, what we're going to do is just like everything else, we're going to get the variable by itself. And in these cases, it's fairly straightforward because we only have one term with a variable, right? There's no x values or no b values. It's just going to be x squared and b squared. So get the x squared by itself and solve. So if I add 10 to both sides, we get 5x squared is equal to positive 10. And then to get rid of the 5, we divide both sides by 5. So we get the x squared is equal to 2. Now remember, this right here, this is the square root property, whereas x squared is equal to some number, right? Now it doesn't actually have to be a number, it can be a function as well, but x squared is equal to something. And how do we get rid of the square? We square root both sides. In order to get rid of the square root and the square, you have to write it as plus or minus the other. Okay. Fairly straightforward. The next problem, one with fractions, we're going to first divide by 2 over 3. So we get b squared is equal to division by a fraction, flip the fraction, and then multiply to the other. Notice we can multiply straight across already, meaning 18 times 3. But because we know the 18 is going to go onto the top of the fraction, we can simplify it with that 2. So there's going to be 9 left over, which is 18 divided by 2. So what we get is b squared is equal to 3 times 9, or b squared is equal to 27. Okay. Now again, variable squared is equal to a number. So we can write this with the square root so that these cancel. And in order to write b equals, we need plus or minus the square root of 27. Now, in this case, it is going to be very dependent upon your teacher. Okay. This is the correct answer. There's nothing wrong with it. However, your teacher might require you to simplify it. So what we're going to do is we're going to take this and then use the fact that square roots are looking for pairs of multiplications of the same thing. So we can rewrite this as 9 times 3 again, which is 3 times 3 times 3. And there's our pair of 3's. So if you have a pair of 3's and this is a square root, you can pull one of them out, which is plus or minus 3, square root of 3. Both of these answers are correct. This is the non-simplified version, and this is the simplified version. So double check to make sure that which answer is required. Now the last one is a little bit different. This problem is going to give us something that we couldn't do before. So remember in the very beginning of the videos that we were discussing the domain of a function, and one of the restrictions was that the square roots or even roots cannot have a negative on the inside of the square root. And that's something which is very important because you'll find here that it follows that property. So 5a squared, if I subtract 10 to both sides, you get 5a squared equals negative 10. Dividing through by 5, you get a squared is equal to negative 2. And then now square root both sides using the square root property. So a is equal to plus or minus the square root of negative 2. So the square root has a negative on the inside. That wasn't allowed. It wasn't in our domain. But what we're going to do is we're going to teach you something which is a little bit of a trick, which is we, as mathematicians, write the square roots and negatives as the variable I, or the number I. So the square root of negative 1 is I. So what we get here is a is equal to plus or minus the square root of negative 1 times 2. So I split negative 2 into negative 1 times 2. And then now we can split it as plus or minus the square root of negative 1 times the square root of 2. And this is going to be I square root of 2. Now, just with just like all of these problems and any of the problems you've done before, you can always plug it back in to check to make sure that your solutions work. So what I'm going to do is I'm going to plug that into here to show you that we actually get what we're supposed to. So 5a squared plus 10 equals 0. We get the a values I, plus I, and plus I root 2 and minus I root 2. So in order to plug in parentheses, I root 2 squared plus 10 is 0. So the square is going to give you 5 I root 2 times I root 2 plus 10 is 0. Where all I did was I used the definition of the square to rewrite it as a multiplication of itself. Now, I times I gives you I squared, and root 2 times root 2 gives you 2 itself. Anytime you have a square root multiplied by itself, you get the number on the inside. Okay. Well, I itself is defined here to be the square root of -1. So let's go ahead and plug that in. So we already know square roots and squares cancel. So this is going to be 5 times -1 times 2 plus 10 is 0. And then this part right here, if you can see, is 5 times 2, which gives you 10, but a -10. So this is -10 plus 10 is 0. And that's true. So if you want, you can go ahead and check the -1 and by plugging it in, but it will give you the same result, that it will be a true statement. So these two are the solutions to this equation.